In this video, we will discuss about maximum number of moves in a grid. You are given a zero indexed m cross n matrix grid consisting of positive integers. You can start at any cell in the first column of the matrix and traverse the grid in the following way. From a cell row comma column, you can move to any of the cells row minus 1, column plus 1, row comma column plus 1 and row plus 1, column plus 1, such that the value of the cell you move to should be strictly bigger than the value of the current cell. Return the maximum number of moves that you can perform. So what they are saying is that in the input, we are given a grid, right? In this, all the cells which are in the first column, that can be our starting point. Then from a particular cell, we can either move towards its right or towards its upper diagonal or towards its lower diagonal cell, right? Only if the values in these is strictly greater than the value in this particular cell. So when you move from one cell to the other cell, then it is counted as one move, right? So what you need to do is you need to find out that how many maximum number of moves you can perform, right? So if you see here, 2 can be a starting point, 5 can be a starting point, 3, 10, all of these can be a starting point, right? So if we start from 2, we can either go here or we can go here, right? There is no cell here. So we can either go to this 4 or to this 4, right? So if you go to this 4, then after this, from this 4, you can either go here, you can go here or you can go here. But in this, the value is 3 and here the value is 2. Both of these are smaller than 4, right? So we cannot go there. So from this 4, we can only go to this 9, right? Then from this 9, you have these 3 cells, out of which only this 11 is strictly greater than 9. So we can only go to 11. Now from this 11, we are not having any cells to traverse. So then that means we cannot go further. So this is one of our path, which was 2 to 4, 4 to 9 and 9 to 11, right? Here, how many moves you performed? 3 moves. One is this one is this one, and one is this one. So total 3 moves you have performed, right? So you need to find out all such paths where the starting points is either of these cells, and then out of all those paths, in whichever path you are getting the maximum number of moves, that you need to return as your answer, right? So now what are we going to do is that, okay, we know that the cells in the first column are going to be our starting point, right? So we will try to find out all the possible paths for all of these starting points, right? So here, as I said, if we start with 2, we can either go to this 4 or to this 4, right? If you will go to this 4, then you can either go to this 3 or you can go to this 9. So this 3 is smaller, so we can go to this 9. Then from here, we can go only to 11, right? So after 11, we will stop. So one of the path is from this 2 to this 4 to this 9 and to this 11, right? So here the number of moves are 3. Then 2 could also go to this 4, right? In that case, this 4 would go to this 9 and this 9 would go to this 11. So here in this path also the number of moves are 3, right? Then the next starting point is 5. Now from this 5, can you go anywhere? No, because all of these values are smaller than 5. So we cannot move further. Then we'll check for this 3. Then for this 3, all of these 3 values are strictly greater than 3. So we can go in any of these. So if we go to this 4, then from this 4, we can only go to this 9, right? And from this 9, we can only go to this 11. So one of the paths is this. Then from this 3, if we go to this particular 4, then from this 4, either we can go to this 9 or we can go to this 13, right? So if we go to this 9, then we can go to 11. So one is this path. Here also the number of moves are 3. And the other is that from this 4, we go to this 13 and then from 13 to 15, right? So one is this path. Here also the number of moves are 3, right? Then if you see for this particular 10, then you can go only to 9, right? Then from this 9, you can go only to 13 and from this 13, you can go only to 15. So here also the number of moves are 3, right? So now we have find out all the possible paths or all the possible moves that we can achieve in our grid, right? Now out of these, whichever is giving you the maximum number of moves, that is your answer, right? So here, what is the maximum number of moves? All are 3. Maximum number of moves are 3 only. So for this, your answer will also be 3, right? So what are we doing is that we are considering all the cells in the first column as our starting point, and we are finding out all the possible paths and calculating their moves, and we are also tracking the maximum number of moves out of these, right? So now let's remove this. So as I said, we will consider every cell in the first column as a starting point, right? So what we'll do is, let's suppose n is denoting the number of rows and m is denoting the number of columns, right? So you will loop in the first column. So I will start from 0 till n it will go, right? And how you will get the first column? So it will be grid of I of 0, right? So this will be your starting point. So since you will be finding out all the possible paths, so you will create a helper function, which will be your recursive function, right? And that will give you the number of moves, right? So for every cell, you will get the maximum move, and for that also you need to find out the maximum, right? So what you will do is you will create a helper function, let's suppose helper. In that, what it will receive the current row and the current column, right? So row will be I and the column will be 0, right? And then other things that we can send is the grid, right? So this will give you the moves, right? This will give you the moves. So let's suppose we keep it inside moves, right? And now you need to find the maximum number of moves. So you can take one more variable, max moves. Initially it will be 0, and then you can update it. So max moves can be updated as maximum of max moves, comma moves, right? So this you are doing for all the cells in the first column. And then at the end you can return your max moves, right? So now what are you going to do inside this helper function? How are you going to identify all the paths? So let's suppose this is the helper function. So this will give you an integer, right? So it will receive the current row, so int row, then it will receive the current column, and then it is going to receive the grid, right? So you can write it like this, grid. I'm not writing it completely, okay? So you will receive a vector of vector, which will be the grid, right? Now inside this, what you will do, you need to find out that if I am at this particular cell, then out of these three, whichever is strictly greater than this particular number, for all of them, I need to find out the maximum moves, right? So what you will do is, you will call this helper function whenever any of these value is greater than this, right? So since there are three directions from 5, we can either move here, here or here, right? So from row comma column, we can either move to row minus 1 and column plus 1, or we can move to row column plus 1, right? Or we can move to row plus 1 column plus 1, right? So in all these three, the columns are plus 1, and for row, here it is minus 1, here it is as is, and here it is plus 1, right? So what you can do is that you can create another array, let's suppose directions. You can create an array directions, and inside this you can write minus 1, 0 and 1. So this is denoting all the changes that you have to do for the current row, right? So you can traverse over this directions array, and then in the first one you can do row minus 1, and then for second it will be row only because here it is 0, and then for this you will do row plus 1, right? And the column is plus 1 always, right? So what you can do is that you will iterate inside the directions. So let's suppose for int direction in directions. So now inside this, what you will do, you will get the new row and the new column, right? Your new row will be equals to row plus direction, right? So in the first case, it will do row minus 1. In second, it will do row plus 0, which will be row. And in third, it will do row plus 1, right? And the new column will be column plus 1, right? Now you can check that if this is a valid combination, if this new row and new column is valid or not. Now, how are we saying is it valid or not? If this new row and new column are within the range of the grid, meaning new row is greater than or equals to 0 and it is lesser than the number of rows, right? And then this new column is greater than equals to 0 and it is lesser than the number of columns, right? And the next condition is that the value at grid of new row and new column should be greater than the value at row and column, right? So whatever is this new cell, its value, if it is strictly greater than the value at row comma column, then only we will consider it, right? So in this valid, I am keeping these three conditions, that new row is within the range of number of rows, new column is within the range of number of columns, and the value at new row comma new col is strictly greater than the value at row comma col, right? So if this is a valid cell, then in that case, what are we going to do is that we will update our maximum move, right? So let's suppose here I have taken another variable max moves, right? And initially its value is 0. So inside this, what you will do, that you will update your max moves to maximum of max moves, comma. So now since we have visited the current cell, which was row comma column, and now we are moving on to new row and new column, so our move, the number of move will be increased by 1, right? So here what we'll do, we will do 1 plus, and then we need to call our helper function again for this new row new column, right? So we will do 1 plus helper, and then inside helper the row will be passed as new row and the column will be passed as new column, and then we can pass our grid, right? So we will do this. So this will give us the maximum number of moves for this particular row and column. So this will close here. Now let me just push this below code a little down. So now after we have got this maximum moves, what we need to do is we just need to return this maximum moves, right? We will just return max moves and our helper function will be completed, right? So what are we doing is that first of all, we traversed for all the cells in the first column, and then we call the helper function where our row was I and the column was the first column, which is 0, right? So it gave us some moves. In the max moves, we are updating the maximum move, and at the end we are returning it. Then inside the helper function, we are taking the current row and current column, and we are taking a variable max moves. Then we are iterating inside our directions, and the directions were these three. Then according to the directions, we are calculating our new row and new column, and then we are checking whether this new row is within the range of number of rows, new column is within the range of number of columns, and the value at new row comma new column is strictly greater than the value at row and column. If it is, then we are updating the max moves with the maximum of max moves comma this. Here we are doing +1 for the current cell, for the current move, and then in the helper we are passing the new row and the new column. And then at the end, out of this loop, so this loop will also get finished here, right? Then outside the loop, we are returning the maximum moves, right? So now here, if you see, we are trying to find out all the possible paths, right? So now this is going to take a lot of time complexity wise, right? So we would need to optimize it. So what we can do is that we can use memoization here. We can create a DP vector, right? You can create a DP vector which will be 2D. Now why it is 2D? Because we are changing two things here, which is the row and the column. So we need a 2D DP where this will denote the row and this will denote the column, right? So here at this point, you can create a DP of size n cross m, right? And then in your helper function, you can pass DP also, right? Then here you will receive DP, right? Now here, before coming inside this for loop, before checking for new row and new column, you can check that whether the value at row comma col is not equals to 1, right? If it is not equals to 1, then you can simply return that value from here. You don't need to go inside this for loop, right? And then here, before returning, you can assign this particular value inside DP of row comma column, right? So this is how we can memorize it, and we will be able to achieve the maximum number of moves, right? So let's code it out now. So as I said, first of all, we would need our three directions. So we will create an array directions and its size will be 3, right? And it will have -1, 0 and 1, right? Now inside this function, what we need to do is, first of all, we will take the number of columns and number of rows. So n will be grid size, which will be number of rows, and m will be grid of 0 dot size, which is the number of columns, right? Then we need to create our DP vector. So it will be vector of vector integer DP. Now what will be its size? N comma vector int m comma -1, right? N cross m, and initially all the values are -1. Now we need to create a variable for tracking the maximum moves. So int max moves will be equals to 0. Now we need to iterate for all the cells in the first column. So for int I equals to 0, I less than n, I plus plus. Then inside this, what we'll do? We'll find out the moves, right? So for finding out the moves, we will call our recursive function. So let's suppose it is helper. Inside this, we'll pass the row, which will be I, column, which will be 0. Then we'll have to pass the grid, and then we will have to pass DP, right? And then we will update our max moves. So max moves will be equals to maximum of moves comma max moves, right? And then at the end, you can return your max moves, right? Now we will create our recursive function, the helper function. So it will return us an integer helper. It will receive row, it will receive column, then it will receive grid, and then it will receive DP, right? Now inside this, what we need to do is, let's find out the number of rows and columns. So n will be grid size, m will be grid of 0 dot size, right? And then we need to check that if DP is already having the value for this particular cell. So if DP of row comma col is not equals to -1, then return DP of row col, right? Then we need to find out the maximum moves for all these three directions. So we'll create a variable max moves. Initially it will be 0. Then we will iterate inside directions. So int dir in directions. So now we will calculate the new row. So new row will be row plus direction, right? And then new column. So new column will be column plus 1, right? So now you have to check that whether this new row comma new col cell is valid or not. So if new row is greater than or equals to 0 and new row is less than n, right? And new column is greater than equals to 0. So we do not have to add this condition greater than equals to 0 because always we are doing plus 1 only in the column, right? So it will never go negative. So instead of this, you can check less than m, right? And the value at new row, comma, new column should be greater than the value at row, comma, column, right? If all of these conditions are true, then that means this is a valid cell. And now we will update our max moves. So we will do max moves equals to maximum of max moves, comma. Now here we have visited the current cell, right? The current cell, which is row, comma, call, that is visited, right? So for this, we will count a 1, right? And then we will traverse for the remaining path, that is from new row, comma, new column, right? So we will do 1 plus helper, and then inside this, we will pass the new row, the new column, our grid, and the DP, right? So now outside this loop at the end, we can return the max moves and we can also assign it in the DP. So it will be equals to max moves, right? So let's run this now. So our test cases are accepted. Now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.